Hi everyone. I'm going to tell you about a concept we've been developing at the University of Florida called human-centered distributed conversational modeling. This concept enables us to much more quickly and efficiently generate robust virtual human conversations, or really the corpus that allows people to conduct virtual human conversations. This concept is specifically for virtual human characters for training applications. Here's a few examples of some virtual human characters. On the upper left is Sergeant Starr, who is used for military recruitment. On the upper right is Justina, who is used for training psychology students. And these are both developed at ICT at USC. And at the bottom is a few examples of characters in the interpersonal simulator. The interpersonal simulator is actually the project that we work on at the University of Florida, and we use it for training healthcare students at Medical College of Georgia and the University of Florida. So to create these characters, they conduct their spoken conversations using a concept called unannotated corpus retrieval. So what is a corpus? Well, here's a small example corpus on the left. It is a set of stimulus-response pairs. Stimulus example is how old are you? Response, I'm 35 years old. And these will actually have hundreds of these stimulus response pairs, hundreds of responses and thousands of stimuli to be able to conduct a corpus, a spoken conversation. And the reason we have thousands of stimuli or questions is because the corpus has to cover the boundaries of a real conversation, which the actual things that people may ask the character are not necessarily what one might expect. So now let's take a look at the process that is currently used. In the current process, virtual human developers put the stimuli and responses into an XML-based corpus. They gather these stimuli and responses using existing material, generally gathered from video. So in the case of healthcare students, it would be interactions with medical students and standardized patients, which are actors playing the role of patients. Then we would go to the experts, which would be doctors, and have some phone, email, and in-person meetings with them so that we can ask them, what are the appropriate responses to the stimuli we got from the material, from the existing material, and what are other questions students might ask. Well, this is a good way to get started, but unfortunately, experts aren't really able to figure out what students are actually going to ask because experts are only able to follow the optimal path. They know exactly what they're supposed to get, but they can't predict how students are going to go off on tangents. So to get that information, we actually need to have the virtual human system interact with novices. Then we take those videos and log files from those novice interactions and get a whole bunch more stimuli. Now, that process can take a couple of hundred hours and over the course of 6 months. The main problem here is that all of this information is going through the virtual human developer. The virtual human developer is a filter to the corpus, and they themselves become a significant bottleneck. So in human-centered distributed conversational modeling, what we do is we actually allow experts and novices to interact directly with the virtual human system, and the system itself gathers all the information and places it into a corpus. Now, the virtual human developer can still be a part of the process, but they're another source of information. So they're an expert on virtual human interactions rather than being an actual filter to the corpus. So what's the modeling process for human-centered distributed conversational modeling? Well, the first thing that happens is an expert uses an online GUI and gives their best guess questions and responses. It's a very simple process for them. They ask all the questions that they expect a novice to ask, and then they answer the questions themselves. Now, because students are interacting directly with the system, they can email this out, and students' user testing occurs online. They ask a few students to try interacting with it, and anything where the student's question wasn't answered correctly gets gathered into a list, and the expert then just goes back later and answers all of the new questions that are there. Then the expert looks at, well, how did it perform? If there's many errors, we repeat the user testing, and with a larger group. And if there were few errors, it's probably a mature corpus and we can go on. We can see that in this highlighted area, this is actually a learning process called case-based reasoning, and the experts and novices collaborate to teach the virtual human how to conduct this conversation. So we created an application called Virtual People Factory, which is an implementation of human-centered distributed conversational modeling. It's a web application. It consists of an editor GUI and an interaction GUI. The experts use the editor GUI to enter responses and questions if they feel like it, and the novices use the interaction GUI to add new questions. And all of this is gathered into a corpus. Now, this corpus isn't very useful if we can't use it outside of Virtual People Factory. So Virtual People Factory also has a web service which allows many different types of interactions through XML HTTP message passing. So we can interact with these characters in Second Life and interact with the same character in immersive interactions and in web browser interactions. Here's just a brief look at what the interaction looks like. It's an instant message interaction, which is familiar to most users, so it doesn't require any training. So we ran an evaluation study to see how this process worked compared to centralized conversational modeling. For centralized conversational modeling, we had virtual human experts, pharmacy experts, and 51 students collaborate to create a virtual human. The resulting corpus has 303 responses and 1,418 stimuli. In human-centered distributed conversational modeling, a pharmacy expert and her own class of 186 pharmacy students were actually able to create the same character. Obviously, the corpus underneath is different, but exactly the same character background without any help of virtual human experts. And the resulting corpus had 595 responses and 2,655 stimuli. Now that's because we've removed the filter, so she was able to do it much more quickly. So we don't have that virtual human expert as a bottleneck for all of the information anymore. So what was our result? Well, with centralized conversational modeling, the final conversational model had 74.5% accuracy, and the distributed conversational model had 78.6% accuracy. And you may go, well, okay, that's only a 4.1% increase, which is significant at p less than 0.05, but it's not something that an end user is ever going to notice. The big thing is, centralized conversational model took 200 hours over the course of 6 months and a huge collaborative effort, whereas the distributed human-centered conversational model took 15 hours over the course of 2 weeks. So it's much more efficient. So what are the limits of this approach? Well, it requires a large group of users who are willing to take the interaction seriously, so they're not putting in just random things which would waste the time of the expert. 15 hours may still be considered a large amount of expert time. However, we found that our healthcare collaborators have constructed 8 virtual humans with over 100 responses each, all on their own, because they actually really want to have these interactions, so they're willing to put in the time, especially educators. They want to give their students these interactions. Now, if we take it down to at least 50 responses, they've actually created 23 virtual humans corpuses. These would be for shorter interactions, maybe 2 minutes instead of 10 minutes. In conclusion, human-centered distributed conversational modeling allows us to efficiently generate virtual humans that are robust for a variety of inputs. This has been deployed at 4 healthcare institutions, and it's open for research use. So if any of you watching this video would like to try human-centered distributed conversational modeling, please go to www.virtualpeoplefactory.org and you'll be able to sign up for an account. And these are the people I would like to thank. Dr. Carol Kimberlin, who actually performed the study and created the virtual human for the study. Dr. Diane Beck, who facilitated a lot of these interactions. Hevel Shah, and all of the guys in my research group, Andrew Rye, Aaron Cutranza, June Shaw, and Kyle Johnson, and especially my wife Elizabeth. Thank you very much, and please feel free to contact me if you have any questions.